nice little algebra problem. We've got 1 on x plus 1 on y is equal to 1 on z, where x, y, and z are all integers. So we'll start by rearranging for y. So what we can say is 1 on y is equal to 1 on z minus 1 on x. And making that into one fraction on the other side then, so we'll have x minus z is equal to xz. And now if we reciprocate both sides, y is equal to xz on x minus z. And now what we'll do is we'll add and subtract z squared to the numerator of our fraction. So that's going to be xz plus z squared minus z squared. So if we then factorize out the z from these two terms, what we're going to have is z lots of x minus z plus the other z squared. And then we can see that this is the same as this. So we can rewrite this as z plus z squared on x minus z. The reason we do this is so that now we know that z is going to be an integer. So this thing has to be an integer as well. So therefore, if we call it w, has to be also an integer. So we'll try and rewrite some things in terms of w then. We know that y is now going to be z plus w. And x, if we think about taking this numerator, taking this denominator, sticking it up this side, putting w back down, and adding the z, we'll have x is equal to z plus z squared on w. So if z is a whole number, w is a whole number, then for x to be a whole number, what we need is to have that this thing is also a whole number. And that's going to be the case as long as z is some multiple of w. So we can say that now. Z is going to be, say, k, lots of w, where k again is a whole number. So now all we need to do is pick values for k and for w, and everything should be fine. So as long as k and w are whole numbers, then that means that x, y, and z are all whole numbers. We have some little caveats to choose, so we have to make sure that kind of it's not 0, like none of them can be 0, we think, because they're all on the bottom of the fraction. So what we have to say is that z cannot equal minus w, so that y isn't 0. So basically that tells us then that k cannot be minus 1. We also have that z can't be 0, so that tells us that k and w both cannot be 0. We could inspect x as well, but what we end up with is the same conditions, that basically k and w can't be 0 and k can't be minus 1. So there's infinite solutions. Are we never then that w and k are whole numbers, such that w and k are not equal to 0 and k is not equal to minus 1.